Welcome everyone in this introductory session for the training about the European weather cloud. So I'm Roberto Cuccu. I work at the ECMWF in the user services section. So I will give you this introduction about the European weather cloud with a particular focus on the ECMWF side of the cloud. So hopefully after this session, you will have some elements to get started using the clouds, and you know the basics on how to provision resources on the cloud and also use the cloud features. So let's start just with a recap of what it is the European weather cloud for who is not yet familiar with that. So European Weather Cloud is a joint initiative between ECMWF and EUMETSAT, aiming at providing a cloud computing-based collaboration platform for serving the European meteorological community and the member cooperating states of the two organizations. So this is a community cloud. So the project started in 2019 as a pilot, and last year we entered in a ramp-up phase for operations. And finally, we declared the system operational recently in September of this year. So who is the cloud for? So who can request access to the cloud? So users of the member cooperating states that are authorized by the computing representative of the respective countries. So we provide the list of the computing representatives on our website, which is also available through following this QR code. Then we also support research and development activities in the context of the ECMWF special projects and EUMETSAT R&D call. The cloud is also available to the members of the European meteorological infrastructure, including organizations such as EUMETSAT. And finally, also it served the official duty of the two organizations, ECMWF and EUMETSAT. So the cloud infrastructure are collocated with the data holdings of the two organizations, and also it is provided the capabilities to access external data sources and also to share the data across the users of the cloud. So in terms of data access, indeed, we provide a set of pull and push service, so for retrieving and getting the data on the cloud resources. So on the ECMWF side, we have access to the Meteorological Archival and Retrieval System, MARS. And also we provide the possibility to have data disseminated from the ECMWF Production Data Storage, EPDS, directly to cloud resources such as object storage or virtual machine. Finally, also users can access the Copernicus data stores via the dedicated APIs. At the same time, on the EUMETSAT side, the users can access and retrieve the data through the EUMETSAT data store and data tailor, or also having the data pushed through the EUMETCAST terrestrial, so for a near real-time data delivery via terrestrial network. So in terms of high-level design, it is provided a user space where the user can find a landing page which provides just the basic information and acts as a hub for accessing different resources available. We have a knowledge-based documentation where users can find articles about how to get started with using the cloud and also more advanced topic. As well, also we provide a blog that users can follow to get the news about what is happening on the cloud. So we provide a support portal that the user can use to request access to the system and also raise questions or report issues. We have also a discussion platform for a more interactive user exchange across the users of the cloud, also helping to build the community. And finally, also an accounting platform that the users can access to monitor the resource consumption in the cloud. So from the user space, the user can access the cloud orchestrator, which relies on a software and a platform called Morpheus, which consists basically on a web graphical interface and also command line interface and APIs. And through Morpheus, it's possible to deploy and manage resources on the interconnected cloud storage infrastructure. So we have one instance of Morpheus running at ECMWF and one at EUMETSAT, and from both of them, it's possible to control resources deployed in that interconnected cloud. And also in this case, we have one cloud infrastructure running at ECMWF and one at EUMETSAT, and both of them are based on OpenStack and Ceph technologies. So, moving towards the more practical section of the webinar, so we introduce the Cloud Management Orchestrator Morpheus, which is the primary access for the users that need to deploy and manage resources in the European Weather Cloud. So through Morpheus, the users have the possibility to have a dashboard to monitor the deployed resources and also reporting capabilities, the provisioning capability to indeed create virtual machines or more complex setup, review all the deployed infrastructure in terms of cloud, networks, and so on, to have also backups of the deployed infrastructure, monitoring capabilities also with the possibility to customize alerts in case something is going on, and also additional tools and administration capabilities for managing that tenancy. So each project on the cloud is called a tenancy, and this is an isolated environment where users are gathered together and the deployed resources are isolated from the one of the other users on the cloud. So as soon as a user gets access to the cloud, first thing that it needs to do is to configure its own users. And that could be done by going through the top right menu, user settings. And then the users have the possibility to, for instance, customize setting up a photo, but most importantly, changing its own passwords, review API access, or if you want, also enable two-factor authentication. The important thing is also to configure the Linux settings, and these settings are basically the user that will be created on the virtual machine that will be deployed, and also create an associated password. This is not enough because we need also to set up an SSH key for getting access to the virtual machine. Indeed, we provide by default just SSH key authentication. So you can press save, and then you can proceed in setting up your keys. So to set up your keys, you need to go under the infrastructure tab of the Morpheus interface, and then access trust. So from here you have a tab, key pairs, and just by pressing the add button, you have the possibility either to import existing key pair or to let Morpheus generate a new one. So in case you have already your private and public key, you can just import your key here. And it is enough just to import the public key if you want to just get access to the VM. So the private key is just needed for integration with the Git repositories, for instance, or using automation capabilities of Morpheus. So for this demo, we just set up a public key, and then we save our changes. Once, let's say, the key is being created, then it's needed to come back to the user settings so that we can update it together with that. So you can see that now from the drop-down menu, it is shown my just created key, and I just need to save or let's say finally configure my Linux settings that are needed to get access to my provision resources. So I press save, and now basically I'm ready to go for deploying virtual machines on the cloud. So now let's see indeed how it's possible to create a new instance. So from here, you need to access the provisioning tab, and then you have a menu instances. So under instances, you press add, and then a menu is displayed containing two types of virtual machines. So we provide a Rocky Linux and then Ubuntu template. So Rocky Linux is provided with the versions of the operating system 9 and 8, and Ubuntu with the version 22.04 LTS at the moment, but we can keep following, let's say, the updates of the distribution. We follow Rocky for Red Hat-based compatibilities. So after that, you have possibility to select the cloud if you have multiple one configured. For instance, you can have the ECMWF and the EUMETSAT one, or just one of them, and then you can proceed in configure a name of the virtual machines. Then you have the possibility to tag your virtual machine according to the type of environment that you are creating, if production, staging, test, or development. And for this demo, we can just select test, and then use also labels that helps you to find your instance in the graphic interface. After that, you have the possibility to customize further your virtual machine. And here you have the version that is linked to the operating system of the instance that you are creating. As I mentioned, we are providing Rocky Linux 9.2 at the moment and 8.8. And we want to go for the latest for this demo. And then going forward, we need to configure the layout. So the layout basically are a template, a configuration of your virtual machine, and we provide the predefined options available. So we have the data layout, which comes with a set of pre-installed software, including, for instance, Mars client and also ECMWF packages to work with the data. Then we have also the generic layout, which is more close to the plain operating system, but still containing some hardening that we applied to the virtual machine images. And then also we have the GPU flavors that you can use. That comes with the NVIDIA drivers that is used with let's say, corresponding plan, get you access for the use of the GPU cards. So going next, we can pass configuring the plan. The plan basically is the actual resource, computing resource configuration that you want to apply to the virtual machine. So we provide this self-explanatory naming convention where you can see the amount of CPU, gigabyte of memory, and also the gigabyte of the boot disk that is assigned to the VM. And from here, you can see different options and also some possibility. We provide the 4 GPU flavors as well. For instance, for this demo, we will set up 4 CPU, 4 GB memory, and 30 GB boot disk as start. Then you can go next to configure the resource pool, which is linked to the cloud. So you can keep the default here, indeed just one available option. And then if you want, you can also add additional disk to your, that will be attached to your VM, and also customize their sites. We have the possibility to set up different networks. So we provide the 2 main networks, the external internet, which assign a public IP to your instance, and then the private network, which is a private network isolated in your own tenancy. So for this demo, we'll select both of them, and then you press add, and you add the private network. So availability zone is linked to the OpenStack cloud with just one option, not mandatory. Most importantly, instead, is to configure the security group. Security group is a sort of firewall that is, let's say, provided for defining the ingress and outbound traffic to your own virtual machines. So it's an IP-based filter rules that define this traffic. You need also to remind that on top of the cloud infrastructure, we have the ECMWF firewall that allows just a predefined and limited amount of ingress ports. So we allow, for instance, SSH on port 22 or HTTP traffic on port 443 or 80. And so we provide consistently with that just 2 security groups, one which provides just SSH access, and one also SSH and HTTPS for allowing traffic. So for this demo, we are fine with just SSH access. So I will just select the SSH security group. So you have possibility to configure the server group affinity and also the floating IP. So floating IP is just another way to assign a public IP to your virtual machine, which should not be used together with the settings of the external internet network. So if you want to use the floating IP, you just need to set up a private network and then also the floating IP. So, but you're fine if you want to just network interface also for the public network, you just find to using the option that we are setting in this demo. So we're going next, we have the tab of the user config with a check for creating the users that you configure in your user settings. And also you have the possibility to have user groups that will be created. So user group are multiple users that if you configure them will be automatically created on your virtual machine at the time of the deployment. Then going next, you have several advanced options like configuration of host name, a domain, time zone, also ports that is needed for using together with the load balancing, and skip agent installations because each virtual machine comes with the Morpheus agent pre-install, which helps also to monitor the status of the instance. And then you have also other parameters and fields like configuring tags or environment variables, and that is needed when working with the more complex setup and app blueprints, which is an automation capability of Morpheus. Then if your tenancy is integrated with Ansible, you have also this field that you can use to apply Ansible configuration to configure your instance, but this is not the only way. So, and indeed, you can do the same using other kind of automation tools that are provided together with Morpheus. And for instance, going next, you have also an automation tab from which allows you to run a workflow, and the workflow can be also based on an Ansible playbook, for instance. So we have a possibility to configure a backup for your instance, and also a life cycle if you want to schedule the power off and power on of your VM. So once going next, you can review the provided information, and you have also the capability to have multiple copies of your own instance. Then you press complete, and then you can start monitoring the deployment of your virtual machine through the interface. You can click on that, and you can see, let's say, through the progress bar, the status of the deployment. You can see that the machine got already a public IP. And if you go on the history tab, you can have also more information about the provisioning status and the different tasks that are performed for, let's say, the deployment of the virtual machine. So once your machine is ready, you have that happens in a couple of minutes. You have you can access your instance. So your instance in the Morpheus interface will turn to green, and by going to the instance, you can also review the informations and also check the assigned public IP. And also you can see you have a monitoring of let's say the resources, and then through the history tab you can review, let's say, the task and that were applied during the provisioning, the configuration of the machine. So after that, you can also check the networks and the corresponding IP that are associated. And if you remember, we selected both public and private. And to get access to the VM, we just take note of the public IP. And now we pass it to a terminal to get access via SSH to the VM. So for that, we need to use your own private key that you have shown stored somewhere, and then the user that you configure in the Linux settings of your Morpheus interface. If you are running an SSH agent, so to refer explicitly to the private key is not mandatory. You just need, it's just enough to SSH the VM to get access to that. you can see that the corresponding IP for public and private network has been set, and users get also pseudo privileges on the VM. So you just need to set your password, and then you can get root access to your VM that you can use to administer it. You can see the number of processors match with the flavor and the configuration that I applied before, and also the memory. You can see 4 GB of memory. So the same will be also for the disk. You can see one main volume of around 30 gigs, and then also further virtual partitioning. So with that, we can test also the installation of a package to show that you can install whatever you want. You are a full admin on this virtual machine. We just install the HTOP package. We can review, for instance, the running process and usage of the resources, CPU and RAM. So this is not the only way to get access to the VM. Morpheus also provides a console that you can use if you, for instance, just have web access. You can still access your virtual machine if you want through this console. This is working with the just with a public IP is assigned to the VM. You can see that just putting a username and password, I get access to the VM, and I can do some operation with that through this console. You can see. So now let's go a bit more in depth on the data layout, which comes with a set of, let's say, predefined configuration that is suitable for ECMWF users that want to get access and work with the ECMWF data. So the data layout comes with a set of pre-installed software, as I mentioned, and this includes, for instance, the Mars client. This is a particular client that allows access to the Mars server that are collocated in the same data center where also the cloud infrastructure is running. So we have privileged access to Mars with better performances. And this client is already pre-installed in your own virtual machine. Then you have a Conda installation, which comes also with a set of ECMWF packages, including EC codes and MetView. And finally, also, we provide the client for using the Aviso notification system to subscribe notification about data availability from the ECMWF model and dissemination systems. So now let's have a look at how to configure the pre-installed client. So we can start from our knowledge base documentation. As you can see, the documentation foresee that you are using a data layout, which comes indeed with the pre-install Mars client. And after that, you can get access through this instruction to your ECMWF Web API keys. And once you retrieve them with just a single command, you can configure your token and your email for your client through just a single command. So let's give an example. We copy just this instruction just to show you how it works. And also I will put also a fake email to associate to this fake client just to show how to configure that. So you can run the command, and then your client has been already just configured with this. Then you can see also internal Mars hidden directory that you have your token, your email credentials stored here that will be used for authenticating you and get you access to Mars. Then you can see also the, for instance, the Mars email. You can review with that. So with just that, we are ready to run a Mars request through the virtual machine. And to do so, we just need to compose a Mars request. So we just open a text file and we'll be putting a request on that. So we'll be try to retrieve operational data from, let's say, forecast data from the level type surface on the 1st of October of this year, base time midday, and parameter 2-meter temperature with just the step 10. And then we want this output data stored in this file, so you can define the path and also the file name of your output file. So once you create your Mars request, you just need to run the client as you are in other ECMWF facility like the DSPC. You just call your Mars client, you typically get your verbose output. You can see that one field was retrieved from MarsOD, no errors reported. So now I'm expecting that my output file has been retrieved correctly, and I will just try to list it, and you can see that the file has been retrieved. So with that, I can proceed showing the Conda installations. So the Conda installation, you can simply activate it through Conda activate to activate the base environment that is providing the VM. And with that, you can see through Conda list, there is a set of pre-install packages as part of the base environment. You see several ones, and then you can also start looking for the ECMWF one, like EC codes, or for instance, we provide MedView, and finally also the Aviso notification client. So now I can, let's say, close, and just we can try to use one of the packages, EC codes. We can see if the gribls command line tool is available. This is part of EC codes, and it is installed and part of the Conda environment. And I want to use gribls just to list the content of my previously retrieved file from Mars. So I will run it. You can see that the command run correctly and is displaying the metadata of my grib file, which contains 2-meter temperature data from the date of the 1st of October. So this is the right data that I've downloaded before. So now we can pass to have an introduction to the Aviso notification system and the client that it is available in the virtual machine. So Aviso is basically a system developed at ECMWF with the purpose of notifying for data availability. And this data availability regards the output of the ECMWF integrated forecasting model, so real-time model output, but also product dissemination through the ECPDS system. So this is meant for automating systems with supporting a mechanism of when an event happens, then an action is triggered and do something. So if we want to review, let's say, the ECMWF data flow, we have an acquisition process of observation when we have the IFS model running with the output that are generated and stored through Mars. Then finally also value-added product generated and then disseminated through the dissemination system to member states and customers. So for each of either the real-time model output generation and also the data dissemination, an event is tracked to the Aviso system, and then also a notification is sent to the running listener clients that can be also from users running resources on the European weather cloud. So via this system, it's possible indeed to work with the data layout so that it comes with already the client pre-install. Indeed, as you can see in the documentation, it foresees to have a VM created with the data flavor. Then you need to have the Mars credential configured. Indeed, also they will be used by Aviso to authenticate your user to the Aviso server. And then finally create a configuration for your own client. So the default configuration is stored in this file by default, and we can then pass it to and proceed to configure it. So first of all, we need to create the hidden folder of .aviso, and then we can create this configuration file. So this configuration file, as I mentioned, we have two types of notification that we can subscribe for. We have the dissemination one, which is linked to the ECPDS dissemination system. And then also we have another type of listener that, let's say, want to subscribe for real-time model output that could be retrieved through the Mars client. So, and this is the type of listener that I want to configure for my Aviso client running on the just created virtual machine. So with that, you can see that there are three main blocks: the event, which is the type of notification that I'm subscribing, a request block containing, let's say, the specification on the data that I would like to receive notification for, and then a trigger, which is an action that will be triggered once a notification has been received. So with that, I can proceed configuring my client. And now I'm ready to start my Aviso client in listening mode for new notification. To do so, I need to activate the base environment since the client is part of that, and then with just a single command I can start my listener. So Aviso listen, and then it will be listening for and contacting the Aviso server for new notification. So if you want to test anyway your listener, it is provided also the possibility to start the listener in test mode and to send test notification to your own local instance of your listener. So we can proceed to that, and we can start the listening test mode. You can see that now the listener is listening at localhost, so the current virtual machine, and is waiting for new notification. So we can open another terminal. We activate the environment also here, and then we will try to send a test notification to my local listener. So I already prepared that. This notification is matching the configuration that I set for my listener before. So we have indeed an event Mars, subscribing to class OD data, stream info, and then also we'll put the test date. Now we can go back and check if my listener is still active. Okay. And then I can shoot my test notification. So now let's go back and see my listener. You can see that the listener received my notification, so it has been properly configured, and the HO trigger has been run and completed. So now we would like to just give you some info about how to configure the listener. So as I mentioned, there are three main blocks: the event, the request, and also the triggers. So the event is basically either dissemination for getting notification if data are sent from ECPDS through the configured destination to your transfer host, or the Mars event for real-time data model outputs. Then we have the request block, which can be configured by using a subset of the keywords used in the Mars language. And you can see that just most of the fields are optionals anyway, and you can tune it according to have, let's say, the kind of data that you want to subscribe for. And then you have the triggers block, and for that there are several options. There is the HO1, which is just print out the notification that has been received. Then we have the log one that will store the notification in a log file. And then most interesting, there is the command one. So with this type of trigger, you can trigger, for instance, a script and also passing it positional arguments, and also have some environment variables set. So you can trigger some actual workflow once a notification has been received. So after that, also we support, Aviso supports the post notification. So in this case, basically Aviso will act as a proxy and will send an HTTP post to some destination using also a Cloud Events standard specification format. And that is useful to interface Aviso perhaps with other notification system. And here, for instance, is mentioned the EWC simple notification service. Then more interesting, it's also the possibility to run Aviso as a Python APIs, and also to use Python function, so to embed either the Aviso service and also triggering workflows or commands through Python function. So in this case, I can just follow this example. So you just need to import Aviso through a Python code, and then defining also a function that you would like to be triggered once a notification is received. Then the rest blocks are the same. So you need to have, let's say, a request that you want to subscribe for, and then also the listener for that, and then also the commands to run the Aviso service. So you can find this information also in the read the doc documentation for Aviso, and also that is linked to a GitHub space where you can find, for instance, other example. Here is shown one that use also ECMWF web APIs to retrieve the data once a notification is received. So now we can have a simple demonstration of how it works through a terminal. So I already prepared this test Python script, which is basically a copy-paste from the example available in the documentation. Just imported the two more library, daytime and prettyprint. So I want to prettyprint my notification. And also I customize my listener to look for a notification in the past. So this is another interesting capability of Aviso that is able to look for past notification in case you want to recover and run the trigger for past events. And that could be helpful, for instance, when there was some unavailability and or a reboot of the VM in these kind of cases. So I will be looking for all the notification also to show an example for that. And then I just need to run my Python code with my test of it. So it's looking for all the notification, and you can see the output pretty quickly. We receive the old notification and the trigger has run. So we had provided an example of how it's possible also to run the Aviso client through its own Python interface. So now let's have a look about some automation capabilities provided by Morpheus. So Morpheus, if you go on the library tab, you have the possibility to create automation. And that comes with task and workflow. So a task can be, for instance, a shell script that but there are several other options like other configuration management tools that you could try out. And then once a task is created, also a workflow can be created which can be composed by multiple tasks. It can be either a provisioning workflow to be attached to the provision of a VM, or operational to be run on demand. You can configure multiple tasks for each workflow, and also dynamic inputs, like in the case that I want to do in this demo. I want to create a workflow that helps a user in creating a new user and customizing during the workflow, when running the workflow, the username that I want to create in a target resource. So to do so, I go through the option tab that allows me to create a new input. Just press add, and I configure it by giving it a name. So my input is a username. Then you have other fields. Then the field name that is needed for referencing to this kind of input also in the automation tools. Then you have also possibility to set interdependency and also to set up the type, which is a text in this case, and also a label that I want to displayed, and defining if the input is mandatory or not. So once you configure that, it's available here, and I can try to reference to that via a task that I'm going to create. So you go on task, you create a new task. So we can call it create user, and then you can it's type shell script. I want to give it pseudo privileges since it's a user creation that requires them. And then I want to run my bash command user add -m to create also the home. And now if I want to reference to my previously created input, I need to access the Morpheus documentation and see how it's possible to use the special Morpheus variables to reference to these feeds in the Morpheus environments. And you can see here that I need to use this kind of variable. I just copy paste, and then of course I will be needing to replace the field name with the actual field name that I used for my input, so my user. So once you do so, you press Save Changes, and so we have our bash script created as a task. Now I want to create a workflow, an operational workflow, because I want that to run on demand. I call it create user, and then I go to select my previously created task, and also my dynamic input, that is username. Then finally, I can press Save Changes to create my workflow, and now I can I'm able to test it over the previously created instance. So I access my instance, and then you can find under the action menu Run Workflow. So here I need to look for my previously created workflow. So that is called create user. Okay, I can find that, and then you can see that my input, my prompt is shown, and I can create my new user as a username that I want to create in the VM. And then I press execute to run my workflow on the target virtual machine. Now you can monitor the workflow execution through the progress bar and having more details in the history panel. You can see that it was pretty quick. And now I can go to the console and verify if my user was actually created or not. So from here, I can see, for instance, if the home of the user was created, and also its ownership. You can see that there is a new user, my new user, and also you can see the ownership is my new user. So that is present actually on the system. So now, having seen this brief example of automation, we can move forward to the S3 object storage. So this object storage is another feature that is provided as part of the EWC environment. And basically, object storage, for who is not yet familiar, is a data storage architecture designed for handling a large amount of files. So in this architecture, each data is stored as an object within containers called buckets. That provides several benefits in terms of high scalability. You can have potentially unlimited number of buckets and objects. Also benefits on the flat infrastructure that this kind of environment provides. So you just reference to the data via buckets and object key to retrieve them, and you don't have, let's say, the hierarchical structure of common file systems. You have resilience because it's quite fault tolerant and the data are redundant, and also you can just add multiple, replace the underlying devices, maintaining the availability of the service. Then you have also possibility to set metadata that is convenient for instance, having you can set retention time for the data, access control list, and so this kind of properties. And then also, thanks to the protocol which runs through HTTP, is also useful for getting access and also sharing. So the object storage provides is provided through the S3 RESTful APIs, which is compatible with the model of the Amazon Simple Storage Service, from which it takes also the name. You can find also more information in our Confluence page. And for that, you can have multiple ways to use the object storage within the cloud. So you have the possibility to create new buckets to the Morpheus graphical user interface, or use a command line tool like S3 command that we'll be using in an example later on, rclone, or also the command line interface from AWS, but also Python libraries like Moto3. So let's proceed to give an example on how to use the object storage. So from here, we have a possibility so the data layout already comes with the S3 command install, otherwise you can install it. And then you can proceed in configuring your client. So you can see that indeed the S3 command is present. I can see also the usage. But you can see that no configuration is yet available. And from here, you need to parse your basic configuration using also the access and secret keys that has been provided during the tenancy creation. So you have an endpoint also that reference to the cloud tenancy that you have been provided for. And from that, you can just need to configure that. So to configure, I want to have another example of automation. And also I remind the user that they have also the S3 access key and secret stored in the Cyper under the tools tab of Morpheus. That is convenient if you, let's say, forgot, don't have them available. You have the possibility to use the Cyper tool that store them in an encrypted way. And they could also be accessed through the automation capabilities from Morpheus that I'm going to show now. So for configuring my client, I use another type of way to use the automation tools of Morpheus, which is to create a script template that I already created here, which basically contains, in this case, a bash script that check if client is installed and install it, and then just apply for each user present on the virtual machine the configuration for my S3 command client. And to do so, it will reference to the variables through special variables to the data, S3 access key and secret key that are stored in my Cyper. So this is convenient if you want to store secrets on Morpheus and reference to them through the automation tools. So once you do that, you still need to create a task. And then this task, in this case, you need to have a library script type instead of a shell script. And then you just need to reference to the previously created tab. You have other options also to run your task and to configure also retries if you want. Plus also there is a menu on the side to review the available Morpheus variables that you can refer in the automation. So once you have your own task configured, you can go to the virtual machine, and like we did for the workflow, we go under Action, and we can have the option to run a task. Just need to call back my S3 command setup, and then monitor the execution as we did before. Then it will take some seconds also to run, and once the task finish, you are ready to go back to your terminal and check if now the configuration is available. It is, and then we can start using, for instance, the S3 command by listing buckets that might be available, like in this case, or also create a new bucket with the make bucket command, for instance, create a demo bucket. And once a bucket is created, I'm ready to push some file to my bucket. I want, for instance, to push all the previously created files to the bucket. So I will be just looping through all of them and then calling S3 command put and for each of them and put them in the demo bucket. As you can see, all the bucket has been all the files has been pushed, and then through the listing, I can see them uploaded to my target bucket. Now let's see another features available through Morpheus, which is how to reconfigure your instance. So you might need to increase the available computing resources for any instance. You just go through actions and then reconfigure. So from here, you have the possibility to either reconfigure the plan, so assign it more resources, or adding additional volumes to be attached to your virtual machine, or also changing the network settings. So for this example, we'll be changing the plan, and we'll give our VM more resources. So we double them. We provide a CPU, 8 GB of memory. You need to be careful that this operation will restart your own instance, and then you can press start. You can start the resizing of your instance. That will take just a couple of minutes to apply the configuration. Your machine will be rebooted, and hopefully then you get more resources available for your own virtual machine just with a few clicks. You can see on the top that also the plan has been changed. So it's fetching, it's already applied the new configuration and also fetch them from the underlying cloud. Now we just need to wait for the process to finish. And yes, so now it's green again, it's running. So I'm able to check through the console if my instance has been reconfigured correctly. So now just access the VM, and then now let's check again the number of processors, for instance. And you can see now there are 8 processors available, and same should apply for the RAM. That I can check to the command shown before, and you can see now we have 8 GB of memory available. So now to conclude, now let's see also how it's possible to flexibly delete some resources on the cloud. You just need to press the virtual machine, and you press the delete button. With that, just ask a prompt for confirmation. You can start the deleting process, and after some time, your VM will be destroyed and will be not available anymore in your tenancy. So with that, I would like to conclude. pointing you to the relevant resources to get in contact with us and request access if you are not yet a user. And now, if you want, I'm available for any question.